Hey, welcome to AUTOMAT Live-Coding. I will skip the usual intro today. Let's get straight to business. So, last stream we were talking a lot about making videos. And I don't want to get into this whole video editing space. It just doesn't feel like a good use of my time. I think eventually, as the technology develops, editing could be automated somehow. I think there are lots of startups in this space, and eventually we will find a tool that will do this editing for us. But in the meantime, I decided that I will make some videos on YouTube, and there will be two kinds of videos. So first, there is this tradition on the future of coding. In the Future of Coding community. If you don't know what's that, you can check futureofcoding.org, and there is also a Slack. There is also futureofcoding.slack.com that you can visit. And on this Slack, there is a channel for publishing 2-minute weekly summaries. And I guess this format is pretty nice because it's very respectful about the time of the viewer. This is something we can do on stream. Our streams are super long, multi-hour, so we can spend maybe 15 minutes on a stream to write some bullet points and then show some stuff on the video. Then there are also longer clips in the streams, which I guess instead of editing them properly, we can just cut them. I saw that many streamers do this kind of stuff. They usually pick trendy topics to attract the most viewers, but I guess we can just roll with whatever we have already on the stream. There is, I guess, plenty of good content here. So that's one. Second is we have new music. You may hear this already. This is a new set of mix tracks. Maybe I can add longer titles. You can download them from the live.automat.org site. In this music I went for this Broadway style extravagant trumpet solos. I think it came out nicely. I like the mood that this type of music sets, so that's nice. Okay, and this is it when it comes for generic announcements. The plan for today is that, so during the last stream we have been developing the design for assembler. It's very unique, I would say, and there are no assemblers like that. So this is how it will roughly look like. It will be surrounded by a strip of lights that will be blinking to indicate whether it's paused or working, or when it's running step by step. So this animation here will actually be used to communicate stuff to the user. We will use different light patterns to indicate what mode the assembler is in, because there will be a couple of different modes. There will be this mode where it executes it finished, but it will immediately re-execute, whenever something changes or whenever it's asked to, or whenever you change the contents of this assembler. So we will have every other light being on, or we'll have a stream of lights being lit. For example, if it's constantly active, if it's constantly running at 100% CPU, we'll have a slightly different light pattern. So that's one. So what do we see even here? This scroll contains a list of instructions, and you can recognize them. Those are assembly instructions. So this is a move instruction. This is another move instruction, and this is a multiplication instruction. So when working with assembly, you will have this list of assembly instructions that you will be able to grab and drag from here and drop them onto this surface. Each of those instructions will then be parameterizable. So if an instruction has a text box, you will be able to connect this text box to external objects so that the external objects can, change the contents of the assembly. Or generally there will be some widgets on top of the instructions that will allow you, for example, to select the register, select the bit width that you want to work in, this kind of stuff. There will be some jump instructions that will allow the user to also connect the assembly into external objects. So here we have our signature cable. Yeah, very easy. Oh, and on the top, so because on each architecture we have plenty of registers. Depending on how you count, on x86 you have x86-64. You have between 30 and 100 registers. It depends if you include the sub-registers in the bigger ones. Or even more if you include the AVX extensions. So the plan is that each instruction, when it's dropped on this scroll, is going to resize itself to cover the register that it wants to use. If you grab this instruction out, you can drag an instruction outside of assembler and drop it, somewhere else, because AUTOMAT is object-oriented, so we can do those things. But there is this table-like structure still here, where if we were to cover the whole of the register set, we would need this a couple meters long, probably, surface to display all of the registers. Some of the AVX registers, they are actually massive. They would look like that. We would have 8 lines of 64-bit values. So this is a regular 64-bit register. So to not pollute this space with 100 registers, we will have a selector on top, like a menu with registers that you can enable or disable. And when you enable a register, it will appear here. If you disable, it will disappear. I'm still working on the style and visual metaphors that we will use, but I think we will go for a collage style. Paper cutouts from old classic art, like public domain, but not necessarily. We can do we can also use AI-generated images here. That's not an issue. And this is just a design, so we'll replace most of those with better ones. And I don't want to use too many blocks. Like, for example, this one. This write instruction. I think instead of something like that, we could use a much nicer visualization where we would have a piece of paper and a hand that writes something on this piece of paper, and then you will be able to replace whatever is on this piece of paper with whatever you want it to be. So there is that. And also those numbers, I think maybe we could move them out so that they would be here. Something like that. I don't know how to remove an object from a group. Exit group. Pop selection out of group, exactly. That's what I want. Come on. Okay, that was just an Inkscape bug. And the machine code we can probably also move here. Yeah, so this way you will have those nice animated widgets in the center, and on the sides there will be a matching assembly and a machine code. Then we have the instruction pointer, which is actually a pointing hand, which is going to be jumping between the instruction as they execute. And if you write a loop, I found actually some cool ways of accessing this instruction pointer between threads that we can use completely without slowing down this thread. So this can actually execute at full speed, like 100%. There will be no locking, no anything like that. And it will just, jump over the whole assembly to, show where the execution is. From cool things, we also have this element here. This is something that I was actually playing with yesterday, mathematically, trying to describe this shape as an equation that we could then render. And I think we can do that. So we could either create a shader that will, using like SKSL or GLSL, that will fill this region. This is one option. Or we can render this as a path using Skia. I still don't know which approach would be better. Skia is probably going to be more maintainable, but GLSL or SKSL is definitely going to give us more freedom. Oh well, so this is one. I also have this idea of... So assembly can be executed in two ways. First of all, we have a dedicated thread to execute this assembly. This way it will be fairly safe. It's not going to mess up with scheduling of scheduling of AUTOMAT. But we could also run this on the same thread. This is a much more risky approach, but I think so. We will definitely have this. Like, this is not a question. We will. I just wonder how we will do this in the user interface. I was thinking about using this set of Broadway lights as a way to represent a thread. So anything that is within this. So the Broadway lights essentially will represent a separate thread. So we will be able to take this scroll out, and when we take it out of this space, this would mean that it will now execute on the current thread. Super risky. I don't know how it would end up, but could be interesting. This instruction can now be smaller because we pulled out the assembly bits. wonder how to move an object into a group. Anyway. As you can see, I'm still working on this design very actively. But actually, I wanted to say that this is not what we are going to do today. The design work, we are freezing it. We will continue it probably soonish. I also wanted to play with Stable Diffusion. I want to feed this picture into maybe not Stable Diffusion per se, but an image generation framework. And see how it can improve the style, because it's very good at composition. Group those things. Move this here. Probably here there will be a button for showing potential registers. Anyway, I'm still looking for a metaphor for registers. I think a piece of paper could be good. A blackboard. I was also thinking about a blackboard. It's hard to draw a tiny blackboard though. I think that given the types of instructions that computers have, a piece of paper would probably be a good analogy. And the colors should probably come up with a more principled way of assigning colors here, because they could signal the data type. Like typically colors and shapes are used to signal the data type. And I think we could do the same. I think we could signal bits and flags as flags. So this is the eFlags register, which contains many flags. It will look like that. It will be just a long flag. And so I went for brown because I think brown and green, together they look nice. It's like white and blue. Okay, so we are actually not going to go with this design. Come on, I did group this. I think this style is actually looking nicer, where it's not consistent. This will be a nice experiment to write a piece of JavaScript that draws this curve here. I like this one more, actually, than this. Anyway. I have a nice idea. So this shape, let me open tiered row. So we have a piece of paper, right? And it follows this shape. I was thinking about maybe if I draw those lines, it will be better to see, easier to see. So I think a long strip of paper could be drawn like that, where it would fold, but behind. And you know, in this direction. That gives us a lot of space for many folds. I mean, when we do this mathematically, it will be looking nicer. Anyway, I said we are not going to work on this design. So yesterday I was playing with LLVM. I was actually doing something that I intended to do on Wednesday. So I built a small version of LLVM and managed to link it to a small program that adds two registers. It fills two registers, adds them, and that's that. And it leaves the value there. Today, I would like to maybe take the first step towards making this part of AUTOMAT. So we need LLVM in AUTOMAT for many reasons. It's a great compiler. And I don't think it's that large. How large is it? Even if we include everything, right? Okay, maybe this is quite a lot. Honestly, I don't think it's that large. So the binary that I built is probably not. It's not using all of LLVM, 17 megabytes. Okay, maybe that's a lot. We'll see. 70 megabytes is not the end of the world. And that would mean that we have a built-in, like, a proper compiler that can do JIT, it can do actual compilation, it can do disassembly. So we can take parts of machine code and convert them into, like, read this kind of stuff. So LLVM actually includes disassemblers also for all supported architectures. So how we will do that? I took a look at some of the internals of LLVM, and there was this one tool here. Let's go LLVM tools, exegesis. It doesn't matter what this tool does, it's something very specific to, compiler crowd. But internally, this exegesis tool, it tries to emit machine code in multiple instructions, so those instruction sets. But then it also has a little bit of a common infrastructure for working in each of those instruction sets. So it's a very nice example to see how to work with LLVM machine code. From what I have seen, we cannot actually do this using just the public parts of LLVM, because LLVM only exposes the intermediate representation and bitcode and those parts of its code externally. But if we actually link against those internals, they just work. There is actually no issue with it. It's just like with Skia. It has a public interface, but if you look behind the scenes, it doesn't really try to stop you from doing that. And this is amazing, because internally it has the full x86 instruction set, essentially. I have no idea what's that. But yeah, when I scroll here, those are instructions. Those are actually x86 instructions. See, there is this push register, push to stack, pop. Yeah. And those instructions, they are actually written in a very strange way. So each instruction is multiplied a couple times. For example, this GMP64. I don't know what's the difference between those three variants. Maybe those are three different encodings of the same instruction. Anyway, so in AUTOMAT, we will be able to iterate over each of those instructions on every architecture, not only on the x86, because there are ways to do that. And then we can ask the LLVM infrastructure, hey, this instruction, what registers does this instruction accept? Like, what are the operands here? Does it take immediates? How many? And LLVM can tell us that. So from that, we can generate some generic widgets, generic like blocks that users will be able to use to work with new architectures. Okay, so the first step towards using this, I mean, a toy example works, so it is possible to do this. And we have some examples of code that is actually doing the stuff that we want to do. So there is a prior art that we can use as an inspiration. the first step is to actually pull this into AUTOMAT. So let's do just that. So the way our build infrastructure works is we are not using Clang. So we are using Python scripts, but those Python scripts can actually integrate with Clang perfectly well. So if we look for any, maybe not Clang, CMake. Sorry, I haven't slept much today. This is an example of a CMake library, I guess. G-test seems to be another one. Or not. Yeah, we are not building our own G-test. So this is the generic code for handling different CMake libraries. We have Pipewire. Okay, Pipewire actually uses Meson. Yes, CMake is unused here. Let's remove that. Let's also remove other unused modules. Rapid JSON is a header-only library. It seems to use CMake, I don't know for what, maybe for tests. Okay, VK Bootstrap, this is another CMake library that we are using. And this seems to be unused. Cool. So we have our new file. 2025. This is the first file in the new year. Let's import. Okay, we don't need that here. How do those other files work? So first we are adding step for compiling. The fast Trigo library. I think fast Trigo, we are including this in third-party dir. So this is bundled. Okay, so VK Bootstrap is probably the best example for us. So in hook recipe, so this is the default place where we can add extra steps to the recipe. We are adding a step that can clone a repository. And then for each build type, we are building this library. I mean, we are adding steps for building this library. So first for invoking CMake, then for invoking Ninja. Actually, this is interesting. We are dependent on Ninja. And then we have this other hook called hook plan, which is executed when we have a plan for building AUTOMAT already. And here we are looking for every object file that includes VK Bootstrap. Okay. And if we are including VK Bootstrap, then we are injecting no, we are just recording this object file. We are actually looking for binaries which depend on VK Bootstrap. Okay, I think we also had this auto linker. I think we can reuse this. I don't like the API. I think we could simplify the API. So let's write. So the approach that I like to use when writing this kind of stuff, I would like to change the way we write those modules. The way we do this currently, I think could be improved. Maybe not auto linker, but so I would like to say that the directory build/LLVM should be fetched from Git, right? We already have some functions to do that. And of course, this is not the proper Git repository. So the proper one for LLVM. Actually, it should be here. I guess GitHub repository is the reference one. Nice. So I want to say that this directory should be fetched from Git. And the order of arguments, I think the order of arguments should follow the usual assignment. So there is the target equals source, just for readability. I don't like this folding. So in the LLVM lingo, they have some names for those src root. This is how it should be called. It's in the build directory, but we are fetching all sources into the build directory. And then we should assign a tag. What tags do we have? I guess those are the most recent ones. Let's go with this one. So I would like to organize this code a little bit better. So in the end, we need functions like hook, recipe, and so on. So I would like to have an object on which I can call those things. Hook is probably a bad name. How do I access the module object? Oh no, this is the C API. I guess ___ module. Czekaj, Python. Module is not defined. Okay, module is a property of functions. Underscore package. Nope. This is the name of the package. Nice. So this is one way that we can access our module. So calling this should be equivalent to calling this. Oh yeah, it's just introducing more I variables. Maybe you can do that, and we don't need a dedicated install. So hook helper is going to be a class that is going to help us install a set of functions. Hook recipe, hook srcs, hook plan, and so on, because otherwise we have to call them ourselves. This is what this autolinker, messing this up. This is what this autolinker did. Okay, so this is one step. The second would be to build it, but then we need to build it under multiple build types. Okay, then we need to specify the build directory where we will put the build artifacts. Where could we do that? I see that typically we do this somewhere under the source directory. So in Skia we have the out directory where we put those things. In libxcb we have the build. I think you can do the same with LLVM. Sorry, this one doesn't usually have the build directory. I created this one myself. Okay, so this command would, within the build directory, for each build type, it would create a bunch of compiled LLVM versions. I guess we should be able to pass some arguments to this function as well. So this will build, like first generate Ninja sources and then use Ninja to build it, or whatever. And this auto linker is going to be very similar to this one. So we will pass a regular expression for the include path. And if the include path is found in any of the files, it will be pulled in. And the thing is, compilation of any files requires this step. So we need to fetch the library before we do any compilation, but linking depends on this. So we have to specify the condition where the linking will happen. So it will happen when we include something that starts with LLVM. So when any source file includes a header, which looks like that, we will apply the other parts of the recipe. I'm really trying to optimize this whole thing. So LLVM is kind of special also in a sense that the linking arcs, we don't know them until we build LLVM. So the sequence of operations here is very unique. Okay, I'll make a short break. I'll be right back. All right. So we have two options. So two options for this problem of link arguments. So when we fetch LLVM from Git, we don't know how to link with it. We actually need to build it, because then it produces a tool called LLVM config that you can call to ask for all sorts of flags. It would be natural to put arguments like that. But like I said, in this case the arguments are deferred. Oh yeah, and we also have build types. Interesting. We just need that. or maybe so we need to execute this and return the result as a list of strings. Not lines, just yeah, actually, how do we split this thing? I think they could be escaped, so for now let's insert a handler. For this case, so that it doesn't happen. At least when it happens, we should see. So we will need to extend our build infrastructure so that when we have a list of arguments for building something in a recipe, those link args, this is a list of strings right now, but I think we can change it so that when it contains a function and not a string, we will just call this function and it will expand to a list of strings. There is a piece of code here that actually invokes arguments. Anyway, we'll just make sure it works. I want the syntax to be similar to the one here. That's not great. So usually a build process has 3 steps. Git, cmake, ninja. So git fetches, or maybe there is the last one, install. And usually we need to wait for the git checkout to continue with our own compilation. Yeah, we could also have run arguments, true. So this is rare that we can continue right after git checkout. If this is the case, then we need to hard code a lot of this stuff. And we could. Those flags are actually not that crazy. We could build it once and then basically, instead of calling LLVM config, we could produce the same set of flags statically here. Okay, let's start writing this helper. I think the safest option is to assume that the build can only continue after installation finishes. So if any of the source files depends on this regular expression, yeah, then we will just block everything until the dependency is built. Would that work? I'm actually not sure. That unfortunately doesn't work. I could also get access to globals like that. I think I can modify them. it worked. Let's also print those two things. Nice. Can definitely do that. Actually, how do we do this? Okay, nice. So this is part of hook. Now we can do get LLVM. Station line 5. Okay. And this is cloning LLVM. We can actually try running this manually. Let's look at LLVM build instructions. You can also add that. It's fairly large. Okay, I think this is done after we do the initial fetch. Okay, let's let our build script do the fetch. I hope the stream is fine, because we are downloading like a lot of data. Okay, we have LLVM. When I run this again, yeah, it shouldn't do anything. Nice. Interesting. Anyway. I think this could be the default. We will have something like single build type. Here we could invoke procedure, but okay, we need to include builds. Oh yeah, I remember, we have a module for fetching Ninja. And it's pretty robust. It should fetch Ninja on any OS. Okay, there is going to be none of this. I will be right back. Oh, okay. This single build time is not important at the moment. I think we should tell our build system what we expect to have when we finish the build process. Okay, let's see if the configuration works. Build time should have a name argument, I think. Oh yeah, this is because within the LLVM project there are multiple subdirectories. Nice. Okay, I think we should set the prefix. Let's see if we are setting it here. No, we don't. Okay, when I rerun this, it should finish immediately, because it sees that the build ninja file is there. If we go to this build, here there is the prefix directory. Yeah, exactly. Okay, what options do we have? So we are specifying the C and C++ compiler. We could also specify our flags. I'm not 100% sure about those. It's funny because LLVM makes the same decisions as Skia when it comes to exceptions and RTI. This LLVM that we are building here, it's actually there is actually a subtle but important thing here. We are not actually using this LLVM to build AUTOMAT itself. This is a library which is part of AUTOMAT, and because of that it has to build using the same standard libraries and the same compiler as AUTOMAT. We could theoretically first build an LLVM that would then be used to build AUTOMAT and also include it within AUTOMAT, but then I think we would have to build it twice. Yeah, first one we would build the compiler for AUTOMAT and then the compiler which is going to be included in AUTOMAT, because they could have different standard libraries. I love all kinds of solvers. They can be used, they are very rarely used, but they can be used to create amazing effects. Or UI libraries. So typically, typically the solvers, they have a nice translation into geometry. So anything that's displayed on screen, when it can be, whenever the stuff that we display on screen is processed by those sophisticated solvers, the constraint solvers usually, it can produce really nice, kind of very dynamic, very fast animations. It doesn't seem to be very geometric, but maybe there is a way to make it so. This looks nice. This looks like a nice tutorial. I will take a look at this, but another time. Okay, so we managed to configure LLVM. There's one thing missing from here, and this is the output. Output from the build process. Actually, let me remove this directory. Configure this again. Now we should have a proper prefix. Let's see if it's here. Okay, there is our prefix. So let's try to install this.
Low pass effect.
So this will build and install LLVM. So this is what I'm wondering right now. We'll need to put some output value here so that the build system can kind of work, connect everything. So we need to find some artifact that LLVM always produces. There are plenty of those. I just listed some here. I'm not sure which ones are side effects and which ones are going to be installed in the prefix. So this is why I'm building this again here. Maybe this LLVM config. So here we will get a new binary called LLVM config. Yep. So this should be a single file which is produced by the install step. Maybe build result is a bad name. I think it should run with multiple threads already. Yep. Let's look at memory. Looks good. It's compiling as fast as it can. Okay, so let's assume this is going to work. Next step would be to do this. And this is something that we can actually compile. Where did I have this autolinker? Here.
Zyga says.
Aye, aye.
Hey. Okay, we are going to do this compilation. Let's call this include regex. Now we are actually entering the difficult territory, because we have to somehow modify existing objects in the recipe to inject link flags and compilation flags and the dependencies, just like we do here. Let's do this. This we will check differently. How does AutoLinker check this? Oh, it actually has more steps. That's actually not a bad idea to do that. Don't need that. Let's copy this. Okay, so here we are adding dependencies. But really, we should do something like one more thing. So after installation is complete, let's add a step or maybe not. I'm not going to save this get output anywhere. I'm going to compute it once and save it in the outputs dict. And do it like that. Okay, so what I am doing here is I am forcing the compilation of the object file to depend on the output of the build. And also in the compilation arguments, I am going to insert a lambda function. This one. Okay, this cursor is behaving weird. I had no idea about this function. Good catch. Okay, and this we will modify in a similar fashion. It should be compile arcs. And link arcs. No, this will not work yet, because the stuff that we are filling here, the built infrastructure doesn't know how to handle this yet. Okay, installation complete. We can see what did we install. In our prefix we have include directory with a bunch of headers. And yeah, in the bin directory we have LLVM config. If I do this, we get a proper include, which points at AUTOMAT build directory prefix release include. I don't like this std. Nowhere TTI, come on. I think I will have to change some flags. I'll be right back.
Says, hello Mahadfort. This is a reminder that TTS only works in English. Please use English in chat. Thank you. Mahadfort12 says,
IO. How are you?
Interesting thing is that LLVM doesn't seem to have installed any pkg-config file. Anyway, so when we build this with CMake,
I donate $100 to support this legendary streamer.
oh, thank you so much. I mean, how would we use $100? So we still haven't used the stuff that Knight donated half a year ago.
Prank.
I mean, honestly, if somebody donated money, I wouldn't know about this until I got a notification on GitHub or something like that. The stream overlay that I'm using is not really connected to Twitch or anything like that. I don't even know if Twitch supports donations. I'm not a partner. Okay, maybe instead of calling this get output, let's just call it output. I will name the arguments and
What are you doing?
we're making a desktop automation app. This is something similar to AutoHotkey if you're familiar with that one. But it's built differently. Instead of a programming language, it contains a bunch of objects that can be connected. For example, this one will react to F3 being pressed. So when I now press F3, it can enable and disable the rest of this system. This one here, this is a macro. So we recorded a macro that presses the F3 key. When I play this, you can see that it's actually pressing F3 for me. And the point is to automate games. Fairly straightforward. It's fairly straightforward but slightly different user interface.
I think you was use a C in first.
I'm not sure what you mean. So right now we are pulling in LLVM because some of the elements of AUTOMAT are going to need LLVM.
How this will help as in life.
It's a game. It's for fun. If you're familiar with speedrunning, This is... okay, I'm not a speedrunner myself, but I like to, when I play some games, automate them after I finish them. And I think this is kind of like a sport. So if you have a game that becomes repetitive, once you fully know how to play the game, then writing a program to play it for you, it's like a different level of playing the game. It's something that I like, and I don't think there is anything like that around. So I'm trying to create a new type of new level of playing games where you make program that plays the game for you.
Hario says,
Cheap viewers on streamboot.com. Remove the space what's a run tab door to get your in.
Mahad12 says,
I mean, you was use Anther Lang programming in first this project. Why you changed to Python?
Oh no, Python is just the built infrastructure. So it's mostly in C++, but Python is responsible for building C++ because C++ is notoriously complex. Every project uses a slightly different way to build stuff. It's not standardized like in Go or in Rust or in any other modern programming language. Whenever you want to compile C, you always need to invoke a sequence of like compiler invocations. Each of them is slightly different. So I'm using Python just to compile AUTOMAT. So AUTOMAT itself is still C++. Okay, what I wanted to add right now was a way to configure CMake, because CMake allows those defines. I want to enable RTTI because I noticed in the console somewhere, not here, not here, and not here. In some of the consoles I noticed we didn't have RTTI enabled. Okay. I am completely removing the build prefix. Maybe it's not a good idea, but okay. I think this step should depend on srcdir and this file. Oh yeah, I didn't use the extra argument, so let me do that. CMake defines. Let's try again. Can change this to exactly empty. And we have to compile everything again, this time with RTTI. Hopefully. LLVM. Seems to be enabled now. think we should be able now to create a new file. Let's call this LLVM test. Let's put the standard header. Basically this file. This is very strange. Why is the C header forcefully put below rows? Anyway, let's look at our build code. So when we compile stuff, okay, so this is how we compile stuff. We have this partial thingy. Okay. I'm actually curious, this function, when it's executed like that, does it look like JavaScript? Does this function get the self as the first argument? Probably not. No, probably not. Actually, here, when I'm processing args here, I could check which of them is a lambda. And replace them. Yeah, this is gonna work. A new problem comes up now. I need to pass the build type here. This layer has no concept of build types. But this one has. something like this, except the argument is going to be replaced by the next loop iteration. It's slowly getting there. We need to do the same thing here. I just wanted to check that. If there are any arguments, I am replacing them with a version of the same argument, but with the first argument bound. And when actually executing this, if argument is callable, I can call it. Nice. Now we just need to wait for the compilation to finish. How is it going? We're almost done. This is the most risky part. This is when we can run out of memory. Okay. Okay, this is the writing route, the standard. Maybe we can change the standard to a higher one.
Knight says,
Hey everyone.
Hey, Knight. Let's try passing this variable. I know they say that only 17 and 20 are supported, but let's see. Yep. How about 23? Okay, the same issue. I guess 20. I feel it's compiling more slowly now. Or maybe I'm imagining things. Honestly, I really don't see why would they specify C++ standard, maybe minimum C++ standard for headers. Anyway, so this is the best way that we can build LLVM with, and I think it should work. We will just need to wait for the compilation to finish and see if we can compile this thing. I mean, we will need to somehow get those things. So Skia is including Swift shader, which is including LLVM. Let's see, Skia source code. Here we should have third-party externals. Okay, there are no externals here. So we could avoid this probably if we compile our own Swift shader. I have no idea what's Swift shader, by the way. Okay. Looks amazing. Apparently this Swift shader is only used on Mac. But on Mac we can use a different, on macOS we can use a different backend. A Metal instead of Vulkan. I don't think there will be any collisions. I was actually concerned that we could have symbol collisions and duplicate symbols, because Skia could include its own LLVM and we could include Skia through Swift shader could include LLVM and we also could. So there was that risk. Sure, we can just do that. It should just work. So unfortunately, we have to recompile LLVM whenever we change CMake flags. This makes sense. But it's a lot of compilation. Okay, I think we resolved that issue. What is CMake? What's the name for CMake? I'm looking for a name of the category, what it is. tool for building. So if we're pedantic, it's not really building anything. CMake cannot build stuff. And let's change this from CMake defines. Let's do it like that. So they are always defined. Remove this because it's always defined and it's always a list, so we can remove different variants here. Cool. I would also like to refactor this function somehow. Nice. We have the modern standard. Great. Now, when I actually rerun this, actually, let's see. If instead of running install py, if I run LLVM test, yeah, it reconfigures CMake. Because I enabled LTO. Okay, instead of build with CMake, let's do configure with CMake. Maybe this should be the same function. This was just complicating stuff. So this is one part, but also I think if we want to access the private stuff, this kind of stuff, then we will need to add an extra include directory. Or maybe we could create a symbolic link. so that in here we would create a directory called LLVM dash full, and that would point here, LLVM lib. I think we could point this to this. Okay, it's still building. I will make a short break and be right back. See you soon. with our compilation going, it's going slowly.
Adrakuma says,
Hello, how is it going?
Hey, I would say, well, I think we're building LLVM for the 5th time today, or more. But it works, like every time we build it, it works. And we have a small test case that actually uses the LLVM internal x86 assembler. I mean, not quite, but almost. We're still not actually invoking the assembly, we are just building some instructions. This is probably the most complex way to use the assembler. There are way easier ways to do it. Should have anyway, there are plenty of much simpler libraries online for assembling machine code. The silly thing is that we seem to have the LLVM all the time. Actually, more than one version. But I don't think it's linked in, so I don't think we have those symbols available. Okay, so how do I install this kind of backdoor? This is really a backdoor. So the hook that I want to run must run after git. But it could run at any position here. Something weird is going on. What was that? Okay, I ran out of memory. Yeah, probably because of LTO. I guess that means we need another option. Again. Let's say that 2 paralleling jobs is enough, because we are enabling LTO. It's good that I have a separate PC for streaming. Amazing. This should crash already. So the nice thing about this is that this is going to be a very well optimized LLVM. Checking some extra terminals. So it should recover. It should recover in a moment, but I don't know how long the moment is going to be. Yeah, the mouse is back. Yeah. There it is.
Why couldn't you terminate it by yourself? Oh.
So the X server became unresponsive. And I guess it killed a bunch of stuff. But look, now I have like 50 gigabytes of free memory. Oh, and it's still linking. Okay, it didn't give up. So it really depends on the number, on the memory that we have. One is the safest option. You know, I might terminate it because I see it still has like 80 targets to build, and this is not something my PC can survive. So the crashes were because I just enabled LTO, and LTO means that it's trying to load all of those. Let's go. LLVM build release. All of those A files. I mean, it's not that much, like 500 megabytes, but it's also trying to optimize them. So it's running a bunch of algorithms on top of the code in those files. Anyway, I was doing something different. Cool. So this nice class, I guess we could use in many places now. It's a very compact way of fetching, configuring, and building projects. Oh, and I should probably also add this run after install. Okay, this is where we need to create the backdoor link, the lib link. So inside the prefix, there is an include directory. LLVM lib. Yep. This is what we want. I mean, we also have this base prefix. I'm not sure we are using it though. Let's see if it's going to work. Actually, we can do it like that. Now when I use one, it should be an error. Nope. Anyway. Another build. Oh, actually this is not that long. Let's watch memory. It's growing. Yeah, and this is the important binary LLVM config. How much is it going to take? Wow. I think I will disable LTO. Let's start from scratch. I think it's still trying to do LTO for some reason. And because I'm creating this symlink, I don't need to mess with command line include flags. This may be broken.
Knight says,
Do you use the paid version of Copilot in Versus Code? Because I think the free version of Copilot displays advertisements, like the K-Make one that just appeared.
I pay the Copilot subscription and Cursor. I'm actually using Cursor. Yeah, actually both of them. I think it's worth it. Especially the Cursor one, because Copilot works like this IntelliSense, where when you type it suggests the completion, but the cursor can also jump to other places, and like it often messes up the code, so it's not always great. But when I'm doing large refactoring, it's pretty great. I just click position in code, it guesses what I want to do, I hit tab, I just navigate through a couple files hitting tab in each of them.
Because sometimes it gives me irrelevant, ad-like suggestions.
So I haven't seen ads in Copilot yet. Actually, that would be interesting, so... So I haven't seen them. With ads, there is also this thing that they're often region locked. So if they are advertising online, they are probably specifying the region. Like if it's an experiment, then they are definitely doing that. And only testing it in some region first. Like a single country.
Just suggested make to you. I think that might be an advertisement.
I mean, we are... So, not here, not in this case. In this case, we are actually using CMake to configure LLVM. So we are not using CMake to build AUTOMAT per se, but its dependencies quite often require CMake. LLVM is one, Pipewire is another one. Or not, sorry, not Pipewire, VK Bootstrap.
Understand Patai Cloud Dot AUTOMAT.
TTS is crazy. It has a bad day. Right. So, while this thing is compiling, I guess we could do the stuff that I mentioned at the start of the stream. A 2-minute summary of what happened recently. I think we haven't done much with assembler yet. We have a part of the design, we have part of the code working. Still too many things to do. So what instead we could talk about might be the rendering framework. It's hard to show. So, a good structure is to first do problem statement. I'm scripting the outline of the 2-minute summary.
I think adding a period dot at the end of every message could solve this TTS issue, because I forgot to add a period. You can add it by default. You can update it in StreamBot.
Good point. One of those. Yeah, I'm slowly taking care of them. This one is actually super simple one, so should be very easy. I guess I could show some graphs here. I will record this in a moment. I just want the compilation to finish. I still expect some issues. For instance, maybe this will not work. Especially if we run this multiple times and this stuff on top. This popen will very likely fail. I don't know what specific error we are going to see here, so I want to get the error message first before I fix anything. I guess we have another document that we'll have to track now, in addition to Skia release notes. And this would be a nice project. I want to record this on the roadmap. To set up LLVM style RTTI. I have a muscle memory for working with Inkscape, so I'm doing a lot of funny things. See. Okay, file exists. Is it the correct file? Probably need to invert. Yep, there is the lib sibling. Nice. Yeah, this is exactly what I said, that we are going to have issue here. So this is reconfiguring LLVM because I'm changing this file, but CMake is clever enough not to rebuild everything. So those are generated files and they are in the generated directory. So when a file is included like that, I think the compiler searches the include path only. We need to make sure that this file is on the include path. We could link to those files from the src directory. So this is one option. Yep. This is not pretty. So this is the instruction for building this object file. Yeah, this is getting a bunch of include directories. I could do the linking. I feel linking would be more elegant, but it could mess with LLVM build process. Okay, actually there are not that many directories here. And I could just manually insert this one. And then lib target x86. Nice, it worked. I mean, it crashed, but we managed to compile and link it. It crashed at runtime. Now I can restart language server. some weird reason it's not really following the compile commands. Oh, look at that. Yeah, when we generate compile commands, we are not evaluating those functions. Let's fix that. This is a little bit problematic. I think here we can expand them. Sorry. Not here. Here. We don't need to pass anything. Okay. Now it's working okay. And we could even say x86 : and it will give us a list of potential values. It's truncated because the list is massive. But I can still browse available values like that. Pretty nice. Okay, we will play with this more on Monday, and in the meantime, let's record this thing. Let's run this event bench. What? Did we not install Pipewire? We have this file here. Did we broke it in some way? Anyway, we are not going to debug this right now. I clearly broke something. I could manually install pipewire. This should be fast. I didn't remove all of the files that I should. Should I build it from scratch? I think I have a running version somewhere. There we go. Okay. Let's try recording. Hello, this is a short status update from AUTOMAT. We haven't done those in a while, so we are going to start now. Most of the stuff that happens in AUTOMAT happens on live streams, and YouTube prefers to show the video part to users. So to create some presence on this video page, we will create some updates like this one. And in this one, I will mention quickly the topic that we've spent the last 2 months working on. It started when we were playing Mario with AUTOMAT. So macros recorded, we tried to play the first level of Mario, the one with mushrooms and the one without any turtles. We were able to play through the whole level, however, Mario tended to behave differently during playback than when the macro was recorded. It was flaky, sometimes it worked, sometimes it didn't. Then we tried AUTOMAT on a different game. We tried automating experience farming in Black Myth Wukong. And that worked much better than Mario, surprisingly. So it's kind of unintuitive, but it worked better in a kind of more demanding game. But anyway, every couple of hours, the character, instead of running towards the enemy and killing the enemy, because that is what the macro was doing, it was repeatedly killing the same enemies. It aligned itself towards the wall and started running towards the wall, and it never recovered from that. And again, it was flaky, it wasn't happening consistently. So we tried this experiment where we measured the rendering time. And it turns out that the event delivery was super jittery. So those are times that we measured like 2 months ago in milliseconds. So each event was delivered with 40 millisecond jitter. This is like more than 2 frames of animation. And also we had that drift. So for every second of event playback, the events were accumulating delay. So we started optimizing this. I have no idea what is the first thing that we've done, but we managed to bring the drift down to 0, and then with more updates, the jitter as well. So the whole thing, I don't remember what each step was, but we totally changed the way that AUTOMAT renders the surfaces. So instead of having a single canvas, which we're drawing primitives on, we've split AUTOMAT into widgets that independently render kind of tiny canvases. Each of them is rendered to a separate texture, and then those textures are aggregated together. The top level renderer doesn't really care about any individual texture being ready before it renders. It also has a mechanism of stretching previous textures so that they are positioned correctly. This results in some very interesting artifacts which are actually deliberate. When I zoom very quickly, you can see the pixelation effect, right? And when I unzoom, you can see for a very short period of time at the edge of the screen there is a noise effect. They are deliberate. Anyway, so this is multi-threading. We managed to bring the jitter and drift of event delivery almost to 0. We can reduce it even more. I'm happy with where we currently are. So this is it. See you in a week, because this is how often we will do those status updates from now on. Bye. Okay, So that was the status update. Slightly more than 2 minutes. Let's see how long it took. I actually have it on a separate computer. 4 minutes. 4 minutes is not the end of the world. Cool. I guess this is also it for the today's live stream. So see you on Monday, where we will either be continuing the design of the assembler object, or more likely is that we will be doing this. We will try to produce and execute some assembly. Anyway, have a nice weekend.